Okay, on this lesson, we're going to be looking at exponent rules, which should be a review. So all of your laws of exponents, and then we will be rewriting radicals on the back. So these are all of your laws of exponents. So anytime I have a base that's raised to the 0 power, it always equals 1. So if I look at this, x to the 0 is 1. And then looking at part B, I have a 1 on top, z to the 0 power is 1, so that will also be a 1. And then, so that's that first law. So anything raised to 0 is always 1, no matter what it is. The second law, we have negative exponent. Anytime I have a negative exponent, I'm going to take the base and the negative exponent, and I'm going to move it. So if it's on the top, I'm going to move it to the bottom, which I did here, or vice versa. If it's on the bottom, I'm going to move it to the top, and that's what I will get. Okay, so notice my base is x, and then it's raised to the negative 3/2 power. So I'm going to move it down, which would leave a 1 on top, and then I would have x to the 3/2 power. So that's how we can make our negative exponents positive. So if it's on top, move it to the bottom. If it's on bottom, move it to the top. So looking at part B here, notice I have my base z, which is the base is what's directly in front of the exponent. So it has a negative exponent, so I'm going to take it and move it up. So I will have now z to the positive 6th power for my answer there. The next law of exponents we're going to look at is product of powers. And product means multiplication. So anytime I multiply, I add the exponent. So notice here I'm multiplying these x's, so I add the exponents, and that gives me x to the 8th power. This next part, doing the same thing, these are z's, so my base stays as z. And when I'm multiplying, I add the exponent, so 2 plus 2/3. So I have to get a common denominator, which would be a 3. So I'll multiply this one by 3/3. So that would give me a 6/3 plus 2/3. So when you're adding fractions, you only add the numerators. So that would be 8/3. You can also use a calculator. 2 plus 2/3, you should get 8/3. All right, so moving on to my next law of exponent, the quotient of powers. So anytime I'm dividing, that's what quotient means. Notice I subtract the exponents. So notice here I'm dividing these x's, so my base is x. I subtract the exponents. 5 minus 3 is 2. Another way of writing or looking at this, if you're confused on that, is there's 5 x's. We're dividing it by 3 of them. Remember, we've talked about it before. Any term divided by itself is 1. So notice you're left with 2 x's, which is what we got for our answer. So that's one way of looking at when you're dividing, you subtract the exponents. Okay. All right, the next one. Same thing, we're dividing, so I have my base z. And then I need to subtract 5/2 minus 1/3. So I need to get a common denominator. So that would be a 6. So I need to multiply each one of them. That would be 15/6. So 15/6 minus 2/6, which would give you 13/6. Again, you can also type that into the calculator. You would do 5 divided by 2 minus 1 divided by 3. And you can do math, enter, and it changes it back to a fraction for you, in case you're struggling with that. The next one, power of a power. So anytime I have a base inside parentheses and there's an exponent on the inside and outside, notice you multiply them. So notice I have this base here of x, and there's a power raised to another power, so I multiply them. That's x to the 15th power. Okay, so then this next one, my base is z. I have a power to a power, so I need to multiply them. Anytime I multiply fractions, I multiply the tops and the bottoms, but notice that's 2/1, so I would get 10/7 for my exponent there. Okay, so next one is power of a product. Notice we're multiplying a and b inside, and then I have an exponent on the outside. So I'm just going to distribute it to both of them, and it'll be a to the n times b to the n. So that's what we'll do on this part here. We'll have a w cubed and an x cubed. The next one, we'll have a y to the 3/4 and a z to the 3/4. Okay, last one, power of a quotient. So we're dividing inside, but we have an exponent on the outside. It's very similar. We just distribute it inside to both of your bases. So this will be w cubed over x cubed, and y to the 3/5 over z to the 3/5. So those are using your laws of exponents. All right, so now let's look at this first example here. So we're simplifying the following expressions using exponent properties. Make sure that your answers always have positive exponents. Okay, so let's look at this first one. So first I notice there's a coefficient of -4 and a coefficient of 8. So I do exactly what it tells me and I divide them. So I'm going to reduce it. That would be -1/2. Then I notice that I have x to the 0 power. Remember, that's just a 1, so I can mark just that piece of it out because just the x is raised to the 0. And then I have some negative exponents. So I'm going to take my terms that, or my bases that have negative exponents, and I'm going to move them. So I will have a z to the 8th on top. I'm moving down an x to the positive 1 now, a y to the positive 5th, and then I still had the y to the 6th, z to the 4th. All right, so notice that I can combine these y's down here. I'm multiplying the y, so I add the exponents. That would be y to the 11th. And then make sure at the end you're checking to see if you have any other terms that are the same. Notice I have bases that are z's, and we're dividing. So when we divide, we subtract the exponents. And your answer goes on top when you subtract them. 8 minus 4 would give me 4, because remember that means 8 z's on top, 4 on bottom, 4 of them cancel. So you're subtracting those exponents and then just rewriting everything else. Since nothing else can be simplified, that is our final answer. All right, moving on to the next one. So I notice we have parentheses, so we're going to have to distribute. But I also notice that I have parentheses and then I have a negative exponent right here. So I'm going to go ahead and take all of that and move it down. So I'm going to have the 8an to squared over a to the 5th in parentheses, and now that is raised to the positive 3/2 power. So I got rid of that negative exponent first. Okay, so now I need to distribute this. Now, notice I have a coefficient of an 8. I need to square that. 8 times 8 is 64. And then when I distribute a power to a power, remember you have to multiply them. That's a to the 18th. And then in the denominator, I have the base a, and I'm multiplying these because I have a power to a power. That's 15/2. Okay, so I have 64, and I have a. Now, notice I have an a on top and an a on bottom. Remember, we subtract these exponents. So you need to do 18 minus 15/2. So my common denominator would be a 2. So I would have to multiply this by 2. So that's 36/2 minus 15/2, which would give me 21/2. Again, you can use the calculator. 18 minus 15/2. Just make sure you put it back in fraction form when you're done. So since I can't combine anything else, that would be my final answer. Okay, let's look at another example. So notice this one I have negative exponent. I'm going to go ahead and move it to the bottom. Now when I move that whole thing, it only changes this outside exponent. It doesn't change the inside one. So I would have 1 over f g to the negative 3/4 h cubed, but that only changes the outside exponent, so that becomes positive. It doesn't change anything on the inside. And then I'm just bringing everything else down. All right, so I need to start working on this, simplifying it. So I'm going to go ahead and just start distributing this. That's f squared. That would be g. Multiply those, power to a power. That's negative 6 over 4. And then that's h to the 6th. Because remember, power to a power, you multiply them. F to the 7th, and I multiply it by 0. Anything that's 0 is 1, so that is gone. You can mark that out. Then I need to distribute that. That's g to the 5th over h to the 5th. So multiplying them, multiply the tops. 1 times g to the 5th is just g to the 5th. Multiplying your bottoms. So I have f squared, g to the negative 6 over 4. And then when I multiply these h's together, I need to add the exponent. So that's h to the 11th. All right, now I notice that I have a g on top and a g on bottom. But since this is a negative here, then I'm going to go ahead and just move that piece up to the top. So I'm going to have g to the 5th times g. Now it's positive 6 over 4. And then f squared h to the 11th. So when we multiply, we add the exponent. So I'm going to have to get a common denominator, which is 4. So that's 20 over 4 plus 6 over 4. So that would be 26 over 4, and we can simplify that to 13 over 2. So again, you can use a calculator if needed. Make sure that you are multiplying or adding your exponents when you multiply. So you should have done 5 plus 6 over 4. Okay, so since my bases are all different, that's going to be my final answer. So this should be a review from Algebra 1 using laws of exponents. So we're just doing more of it. Now let's take a look at the back. Okay, so we are rewriting radical expressions with rational exponents. So anytime we have a radical, that's this bar right here. Okay, so the little number that's on the outside is called the index, and then the term or terms that are under your radical is called the radicand. So it says the blank is the square root symbol, so that's the radical symbol. And then the blank is the small value on the outside of the radical symbol. This is called the index. The blank is the expression inside the radical symbol, which is called the radicand. And then over here on the other side, the expression square root of x has an index of 2, even though there's not a number there. So that's understood. You have to know if you have a square root, the index is 2. It is known as the square root. Radicals with other indices will explicitly state the index. So the cube root of x, notice the index is 3. So everything else besides the square root will have an index on it. So you have to know square root has an index of 2. So radical expressions may be written with rational exponents. Rational means fraction. The terms rational exponents indicates that the exponents may be integers or fractions, but won't contain irrational numbers such as pi. So the index of a radical becomes the denominator of the exponent. Okay, so what I like to do is when I have a radical and I change it to a rational exponent, I like to just move this out in front, and that becomes my denominator. So for example, see that n, it gets moved to the denominator, and that m stays in the numerator. So my index always becomes my denominator of my exponent. The exponent stays as the numerator. All right, so we're going to rewrite the radical expression with rational exponents. Assume all variables are positive. So this is a 2. So I'm going to rewrite it. Everything under the radical needs to be in parentheses, and since there's not an exponent, all that's raised to, I'm going to put a 1 and a 2 there, because this becomes my denominator, 1/2. Now I need to work this out. So I'm going to distribute it. It would be 5 to the 1/2. It would be j to the 1/2. And then remember, power to a power multiply. You would have k. 3 times 1 is 3 over 2. So we're just rewriting it. We're not having to evaluate. It says, what is the index? The index is the little number that we didn't have on this one. It was a square root, so a 2. So now I'm going to do the same thing on this one. So everything under the radical needs to be in parentheses, and then that becomes the denominator. So I'm going to put 1 over 5. So anytime we have a square root, that means you're raising something to the 1/2 power. Anytime you have a fifth root, you're raising something to the 1/5 power. So I need to distribute this. That's m to the 1/5. And then I'll multiply the tops. I get 10 over 5, which I need to reduce it to 2. The index is your little bitty number, which becomes your denominator of your rational exponent. So we need a 5 there for our index. Okay, so let's do another one. So everything, I need more room than that. Oops. So everything on the inside of your radical needs to be in parentheses, and then that index becomes your denominator. So that's to the 1/3 power. So I need to distribute it. That's a to the 1/3. That's c to the 8/3, because remember you just multiply the numerators. And then that would be b to the 12/3, which reduces to b to the 4th power. Okay, I wanted to know the index. The index is your little number, the root that you're taking, which is 3 here. So this is another way of writing a radical, is using a rational exponent, which is a fraction. So key is knowing the index. That always becomes your denominator of your rational exponent. Okay, if you have any questions, please let me know.